Hey guys.
Hi.
Hey, Ali. Good morning.
Can you guys hear me?
Yeah.
Yes.
Perfect.
Yeah.
Okay, cool. Let's make a bit of a start. Thank you everyone for joining our webinar today. This is the second Databricks webinar as part of Source Talks community. I'm just going to give you a quick overview of Source Talks community and SGI and how we started up this online community. We launched Source Talks in the midst of the pandemic as we were looking to further communicate with our customers and with our wider community around subject matters and technology areas that are specific to talent attraction and the challenges we face. So we've partnered up with a variety of different customers to present and deliver webinars like the one today. So thank you so much for joining. As I said, we will have questions at the end of this session after the main presentation. But if you do have any questions at the, during the presentation, please do pop them in the Q&A and we will follow up when we do have time. But thank you so much. And I'll hand it over to Ralph from RevoData.
Hey, everybody, and thanks for joining again. Before we get started diving deep into the content, I first want to start to look back into what we talked about in our previous session, Databricks for Dummies. And in this session, we did a bit of an engagement together with the audience, so with you. And we looked at where do you apply most of your focus today. And it's quite interesting to see that most of the organizations, people who attended the webinar, are really stuck into the diagnostics analytics. So why did it happen? Not many of the attendees went into the predictive analytics and to determine what will happen next and how can we make it happen even into the prescriptive analytics space. We think that's often due to the fact that the technology is hindering us to move from A to B quickly. And also if you move to the next slide and you look into the areas where we focus the most, it is systematic. There are still different content types, still treated differently. There is a vision, there is agility, but it's not transformational yet. And I think if we look into where we spend most of our time and effort today, it's still within the dashboarding and visualization space. And it's still within the decision support stage. And that typically supports the statement of 2 slides back, where we see that attendees and organizations really struggle to make that leap into the world of data science, AI, and ML. I think, and we think from RevoData, that this is mostly due to the fact that technology can be difficult. And if you haven't chosen the right technology for your data platform, it's not going to help you to move into the sweet spot with automated decision-making. And if you map that into the technology budgets that are available for teams, as you can see, what we pulsed the other day is that IT budget aren't that extensive yet. So still, they're often still quite small. So the question becomes, even with talent scarcity at the moment, how can you achieve more with less? And this is really where our value proposition kicks in. It's building a strong ecosystem of partnerships with Databricks at the core, but complemented with technologies like a Fivetran and a DBT, but also with ThoughtSpot, really accelerating data consumption and moving away from the traditional dashboarding factory model, which we're also going to touch upon later today. Right now, I want to hand it over to Rens, who's going to explain you a little bit about this session for today, and feel free to join this happy ride.
All right, thank you, Rolf. Hi, everybody. I'm Rens. I'm a consultant at RevoData, specialized in data product management. And today we'll dive deeper into Databricks. And first we'll dive a bit more into why Databricks, where it fits in, move into also some technicalities, showing you actually what Databricks is. And as a cherry on the cake, we also have ThoughtSpot in our session to show how easy it is to basically connect with a self-service analytics tool directly on your data lake. During this session, you can pop the questions that you have in the chat. Presentation will be shared after, so no need to print screen. So look forward to your inputs. Susa, if you can go to the next slide. Then we'll start off with this one. This is probably familiar for you. This is basically the journey that organizations take in data maturity, and step by step getting more value out of data. It starts basically looking in hindsight, just like Rolf earlier explained. Most organizations are doing this part, looking at what happened with reporting, also a bit of self-serve analytics. And this is usually available in companies with data warehousing technology. However, big data came around the corner, and having bigger volumes of data, bigger speeds of data, and also more variety of data formats. Yeah, data warehousing technology didn't fit anymore. So a data lake was basically developed as a part of the modern data stack. With big data, organizations have the possibilities to be a bit more predictive and focus on what will happen. So you could basically do more with data. However, still supported with two types of technologies, either the data warehouse to look in hindsight, and with the opportunities of big data to look a bit more into the future. But the focus is still on then the two technologies. And often you see basically those two worlds bring also some challenges along, because if you have use cases that you build on your data lake, they're not directly end-to-end also with the reporting stack around, on top of it. So it's really difficult to get the use case basically alive, both the use case itself as well as reporting on the effectivity on it. So organizations basically make the data not only available then in the data lake, but also, for example, in a data warehouse. And then you see duplication of data rise. And with that, the challenges that it brings to join the data between the data warehouse and the data lake. With that, there comes also a challenge in security and governance, for example. So how do you, for example, if you talk about customer data, have these same authorizations applied in your data lake as well as on your data warehouse? So this basically creates risk in data security, but also basically confusing your users that are looking for data to access it and to use it in their analytics. So Databricks brings a solution to that and brings those two worlds together in what I call a lakehouse platform. And this is what we'll be showing you today. Databricks tries with a lakehouse to simplify the data landscape and the usability to work with the data. Basically to complete the use cases and get better adoption. It works on your main cloud providers, so that are all known to you, like Azure, AWS, and GCP. And it's especially a great solution if you also in the future want to go more into multiple clouds. And this is what organizations more and more do at this moment, and will do further in the future. And that, together with also the open source nature of Databricks and the focus on open standards, makes your company as well while using Databricks quite future-proof. So you not get easily locked into one software vendor, just like what happened in the data warehousing technology stacks earlier. So how does this actually work then? And how does it integrate with your cloud data architecture, such as Azure or AWS? Let's look at two reference architectures. Here on screen, you see one of Azure, and we've got also one of AWS. I'll go over it in in high level, because we don't have time to discuss all the different technologies mentioned. But on the left, you see the data sources, and on the right, you see the business use. And the data flows basically from left to right, and you can follow the small numbers 1 to 5 in the middle. So usually you have the batch processing data from the databases, as well as streaming data, and they come all together in your data lake. In this case, your data lake storage as a landing zone. From here, basically, Databricks starts processing the data into what they call a delta lake, and this is a quite interesting concept. I'll go over that into a bit. With the delta lake, data gets prepared to use in analytical or data science use cases. And that can be, for example, with the native components like Power BI, or with the self-serve analytics for the cloud tools like Approx.what be enabled. Or you can use for data science, for example, into your Azure native components such as Azure ML or Cosmos DB to serve it out. A similar thing works with AWS. So basically the same template, alike technologies. So you have on the left again the databases, your streaming data such as sensors, going into your S3 through either Kinesis, Glue, or Fivetran. And Databricks then is your data processing engine, enables the data through the Delta Lake, and makes it and prepares it basically for your analytics and for your data science use cases. I can imagine that you right now think about, hey, why would I put this Databricks then into the heart of my data landscape? This is all bringing basically the advantages of the data warehousing technology and the data lake technology together into one platform, the Lakehouse platform. So basically, what it does is it creates a data lake more reliable and more performant. I put on screen 6 advantages of a Delta Lake, where Databricks basically does the puts basically one of the 2 foundations together with Unity Catalog of Databricks. So Delta Lake and Databricks work with asset transactions, and this basically means that when you transfer data, a certain batch is an all or nothing approach. Some data that would fail in the middle basically quits the transaction and doesn't commit at all. So you don't struggle with incomplete data in your analytics. So this helps with the reliability of your data in your data platform. Another interesting feature is versioning. Whenever you store data in your Delta Lake, it is versioned, and every update to it is kept in a transaction log. And this is quite interesting because you can go back into previous versions basically to audit your changes, but also you can go back to a certain state on where the data was at, for example, March this year, and see how your forecasts that you did in March this year actually resonates or not. Number 3 is schema enforcement, and this is also a really important part of your data reliability. So Databricks with Delta Lake, you can define a schema, and with that enforce that data that's coming in is aligned to that schema. So you won't struggle with any corrupt data or incorrect data anymore that breaks down your analytics or your data science use cases. Another super interesting feature is upsearch and delete, number 4. What earlier is the case, and what still is the case with data lakes, is that whenever you do an adjustment on, for example, your sales data, you have to completely process the file that contains the sales data of a certain day. With Delta Lake, it's not the case anymore. You can do upsearch, and it's basically concatenation of update and insert. So you can make updates and inserts directly on the existing file, and also deletes, by the way. And this is a really great feature to not have a lot of overhead in your processing. It makes it faster, and it makes it really easy to use. Then there are more features for basically getting better performance in your data lake. One of them is data compaction, and that's also an interesting one. So Delta basically manages the file size of the data that it's in. So often what you see, for example, with sensor data, there are a huge amount of small files, and to read any one of these files, it takes a lot of overhead, a lot of performance. And Delta basically manages the file sizes and optimize it to be as fast as possible. And another interesting part and that's really some good learnings from the data warehousing technology, and that is regarding indexing. So you can, with Delta, apply indexes to your data. Also, I would call here skipping. It's able to cluster your data so that it's only queries the right data for the query that you're firing, and it's caches basically highly accessed data to be as performant as possible. So really interesting, and I can imagine that you're looking forward to see how Databricks does this, and how Databricks looks like, what the UI is, what Delta looks like. And for that, I'm passing over to Susa to give you a bit
everyone.
more. Yeah.
Okay, hopefully you can hear me. And I do apologize. I am in an open office, so there might be a bit of background noise from time to time, but if it's too unbearable, try to read my lips, basically. So essentially, if we move in, so to introduce myself, hi everyone, my name is Zuza. I am a data scientist / analyst from River Data. And we will now go through multiple demos featuring various functionalities of Databricks at a high level and sometimes a bit of a lower level to give you an insight into how Databricks can power data and AI solutions. For the first demo, we will explore the Databricks UI, show how data is ingested into Delta Lake, load some data, save a Delta table, and review the Delta transaction log. So let's quickly jump into this. So actually, before we jump into directly the demo, I want to actually turn your attention to the UI of the Databricks platform. Available through it are various different tools and features that enable respective parts of the data processing journey. And they are actually usefully split up into 3 paths, depending on what functionality is required. So namely data engineering, data science and engineering, machine learning, and SQL, and each have different specific tools to enable the data journey. But we will sit in the machine learning part as it's part of the later stages of the demo, essentially. So to start, we will go through how data is ingested into Databricks for subsequent processing via a notebook, which is one of the types of workspaces that can be used to run these jobs. The notebook allows for live collaboration between team members. So, 2+ people could be editing the same notebook in real time. And it enables the usage of different languages such as SQL, Python, Scala, or whatever is necessary. And just a little heads up, the code blocks have been already run in the interest of time. Hopefully that's a bit more visible, actually. hopefully. The code blocks have been already run in the interest of time. So with Databricks, you can ingest data from hundreds of data sources incrementally and efficiently into your Delta Lake to ensure your lakehouse always contains the more complete and up-to-date data available for data science, machine learning, and business analytics. In this context, actually, RevoData has expertise in data ingestions, both to the cloud providers with Fivetran, as well as into Databricks with a focus on reliability, scalability, maintenance, and support. So in this first demo, we are ingesting a simple CSV file and pushing it to our Delta Lake. To start, we have data already sitting in S3 externally, which is linked to Databricks via a cluster. A cluster is a set of computational resources and configurations on which you run workloads. Let's actually have a look at our specific cluster, which has been amply named after Renz. It's not named after him. So here we can configure and explore the activity of the cluster on a very granular level and adapt it to fit our specific data needs, be that a specific worker type or specific runtime version, usage, event logs, Spark UI can be accessed also through here. So it's very easily configurable. Let's just go back. Okay, and going back to Notebook, we can use it to load our data into the Delta Lake. So there are different ways to go about this, but I would just be using some SQL code and a copy into and create table statement to create a global table in Delta Lake. So copy into allows users to incrementally load data from cloud object storage into Delta Lake tables. We can also use autoloader, which efficiently processes new data files as they arrive in cloud storage without additional sort of setup. We can also use things such as Terraform to manage the Databricks workspace and the associated cloud infrastructure. So there are many ways to go about it. I've just happened to pick this one. I can also, actually, I've covered those. So now the data is loaded via Delta, its metadata can be seen from the data tab. So we have loaded a table called global temperature and temperatures by city, and we can see it sitting here already, and that can be accessed, and we can explore its metadata when it loads. There you go. But we won't go too deep into this part. Let's just go back. So, and it also can be displayed directly in the notebook by a simple SQL command. We can also create a Delta table. And when a user creates a Delta table, the table's transaction log is automatically created in the Delta log subdirectory. And when changes are made to the table, they are recorded as commits in the transaction log. And I know those are quite big terms, and I'm kind of throwing them out there, but basically they build upon what Renz was talking about the versioning, about the time travel, about the keeping of all the versions. And yeah, so we won't be going too low level in these. A Delta directory can then also be registered in our data source. So if we have a look at a Delta transaction log, we can see how Delta essentially stores the versioning of the data or things such as partition files. So here we have our Delta folder sitting in S3. We have our Delta log within that folder, and then we have our transaction log within that folder with separate files for each. And we can see how Delta stores the versioning of the data or things such as partition files. So each transaction log contains various statistics and metadata about the data on a granular level, and each can be accessed via Delta Lake to enable time travel within the data, refer to earlier versions, or examine the history of data and through its sort of level of automated documentation. With this sort of quick demo of Delta Lake, I hope I haven't put too much information forward, but I want to pass it back to Renz to explain a bit more about the structure of processing data in Databricks.
Thanks, Susan. Yeah, so what you just saw is how easy it is to ingest data into a data lakehouse platform. And with that, enjoy all the advantages that the Delta Lake brings. From here, data is still raw. So we got data, in this case, we got data from a CSV file. It can also be a text file, JSON file, Apple file, and put it into your first raw layer, what we call it sometimes in a medallion architecture as a bronze layer. In a medallion architecture, which is basically the best practice for your data engineering. Your data is first in a raw state, and then we prepare the data in the next stage, in the silver layer in this case, to clean it, to take out all the unwanted data. Also apply, for example, a partitioning on it, but can also be, for example, that you want to apply integrity rules such as primary keys. And basically have the clean data available for your reporting and insights, or for your data science use cases. You can also take a further step into a gold layer. And this is where you can, for example, apply aggregates for performance reasons. So all of these are Delta formatted. So all of these are basically your Parquet files with this wrapper around it of Delta, this meta layer, where you can enjoy basically all these benefits. So now the data is in raw. Maybe good to have a look at how this data moves from raw to silver, and see how easy it is to basically enjoy the privileges of having a data lake with also data warehousing benefits.
So in this second demo, we will build upon what we've done already and perform some exploratory data analysis, run some pre-processing on our data, and save them to a silver table. So let's go back. So when we first loaded the data into Databricks, into the Delta Lake in its raw form, as Ren said, we referred to that as bronze tables. Let's now go over how to create silver tables that will later be used for a machine learning model. Sort of without going into too much detail, we're using a publicly available data set, that global and city temperatures, basically. And it contains data on daily temperatures aggregated on different levels, such as state in the US, country, and we're using one by city. We can perform exploratory data analysis or ad hoc tests to determine the best pre-processing and run this on a very large data set in a short amount of time. So here what I've done is basically you can load in the data as a PySpark data frame, and then you can enable very quick ad hoc graphing. So for example, I want to look at the distribution of average temperature, of the average temperature, actually, for being specific. And I can now store that artifact, and I can explore that very quickly. And being able to explore data distributions like this is very powerful for being able to check outliers, checking for missing data. And from there, we can start forming our strategy for the pre-processing and whatever ETL processes are needed. I can also check the data types and any unique values, because that will, of specific variables, because that also comes into the modeling that will come thereafter. To prepare this data for modeling, various forms of ETL processes have to be performed, which can easily be done directly on the same notebook. For example, from my exploratory data analysis, I found a column, actually 2 columns, so the latitude and longitude, which needs to be split, converted to a new data type, because right now it's an alphanumerical object. So it has a coordinate and then it has a direction. So you have 34 point something north. They need to be converted. They need to be vectorized in a different way, because one is a numerical, one is a categorical. And that will form the inputs for my machine learning model. So I can do all of this directly here. So yeah, this big code of block does that, and we won't be looking into each one. I know it's quite heavy on the eyes. With our then transformed data, we can now form our new augmented silver table, which can be used to fuel directly analytical solutions or data science processes, or be further processed to form more aggregated gold business level tables, which can directly be used for reporting, for example. So here, now that this is run, we have saved our silver tables, and we can also access it. Oh, excuse me. We can also access it. It's right there as well. So let me close that. Finally, yeah, we've saved it with a create table statement, and it's now a global Delta table. And if we move back to our presentation, now that there is the appropriately processed data, let's explore how Databricks enables and drives powerful data science solutions. So Databricks allows for a streamlined and end-to-end data science workflow. So starting from the data prep that we just had a look at to the actual modeling and the generating of insights. Databricks also standardizes the full machine learning lifecycle from experimentation through staging, deployment into production, and it helps with automated documentation and naturally generated notebooks. For example, when we dive into things like AutoML, which we'll touch upon a bit later. Furthermore, being built on Open Lakehouse Foundation and open technology, teams can access, explore, and prepare any type of data at any scale via Databricks, and Databricks can accommodate for those different situations. So let's move on to a third demo. And now let's have a look at enabling data science via Databricks by examining ways to run machine learning models directly in the same notebook via either just in the notebook or via MLflow, as well as a quick nod to other functionalities that enable automation and acceleration of the end-to-end data science process. So if we jump back into our notebook. So let's have a look at building a simple machine learning model with our silver layer data and exploring a few of the features of Databricks that simplify and amplify the process. In our notebook, we are able to load the necessary libraries and run a standalone model, in this case, linear regression. And we'll be using that to predict the temperatures based on coordinates of a city. And then we can load and code because we have categorical variables and we have numerical variables, and they need to be prepared in different ways for a linear regressor. We can also split our data into test and train our model, and evaluate the model right here on the notebook. However, Databricks enables the easy use of MLflow. And what is MLflow? So MLflow is an open source platform for managing the end-to-end machine learning lifecycle and offers model tracking, model repository, model registry, projects, model serving, which allows control of access to models via endpoints, essentially. And Databricks provides a fully managed and hosted version of MLflow, integrated with enterprise security features, high availability, and other workspace functionalities. So using MLflow, we can run the exact same model in this framework, which enables new functionalities such as experiment tracking. So each different run with slightly different variables or any sort of start or middle conditions are different experiments. We can track each experiment run and the results from it, such as accuracy or any other sort of artifacts, the type of model used, and all of this is available through a single notebook end to end. Separately, we can also save the inputs to the model, which are otherwise called features, in the feature store, which is positioned right there, but we will be diving into that now. And we can save those for easy implementation into, for example, other models and storage for future projects or exploration of some sort. We can also save models in a repo, registry repo, and easily stage them through production, as well as easily replace or update models without downtime. But we won't be going into sort of each separate feature. So for example, this MLflow model, the experiment has already been saved by the running of this, but we won't be going into too much detail. But this is possibly a deep dive we can do in a future session. Let's go back to where we were at the very bottom. Databricks also enables users to use AutoML to automate the entire setup of a machine learning model and automate MLflow tracking in a glass box type of approach. And that's a whole separate beast of a subject that you could have 5,000 sessions on, but we'll keep it at this level for now. And finally, so now having the processed data and prepared a machine learning use case, the data can then be made available via a connector in Databricks to various BI applications, such as ThoughtSpot. And I know I've been told by ThoughtSpot that they have a button coming up here soon, or different other BI applications. And here to give us an overview of ThoughtSpot is Ali, who will promptly be sharing my screen. So I will just stop sharing.
All right, can you guys hear me and can you see my screen? Yep.
Yes.
Okay, all good. Okay, my name. Thank you, Zuza and Renz and Ralph for the introduction. Let's jump and see how this all works in a live demo. So ThoughtSpot, as it was alluded to, is a search and AI-based BI platform. It helps you get speeds to insight using natural language search terms. So let's show you how this can be done. So as you can see on my screen, this is not something new that I'm showing you. You have seen this before. You've experienced this before, also known as a dashboard. But how the data gets into a dashboard, who creates that, the journey matters. And at ThoughtSpot, we believe the fastest way to get to an answer is through search. We use search daily in our lives. We Google for everything, for restaurants, for the weather, everything else. So why not use search, natural language search for your data? So let's see how we can do this. So in this demo, we are a subscription streaming service analyzing factors driving user acquisition and churn rates. So it's all about marketing campaigns, etc. So let's see how we get here, right? I'm going to start by quickly creating a connection to my Databricks, right? I can do a connection here, create a Databricks connection, just call it whatever I want. I enter all my details. I'm not going to enter all my details right now and pull all the tables, but essentially you get the idea. And then it creates, I'm going to pull 9 tables out of my Databricks instance here that are needed for me to do some analysis on my user acquisition and churn rates. So I'm going to pull all these 9 tables into ThoughtSpot and start searching. So let's do some searches, really quick searches. Let's say, oh, one more thing in the search bar, you see it's already prompting me all the search terms that are most popular. So in this case, I'm going to start using number of customers and the show name. So let's go take a look at that. So ThoughtSpot recognizes this English search terms, right? Creates a SQL, sends it to Databricks, runs the SQL, Databricks sends the results back to ThoughtSpot. ThoughtSpot then creates the visualization and presents this to the users. So you saw me within a couple of seconds, I could ask a complicated question in 2 search terms and get an answer. Here is the query visualizer. So this happens on the fly. There is no predefined drill paths. There is no data prep or data movement or data curation, cubes, aggregates. What I did, the SQL runs directly into Databricks, And here's the query visualizer. So this was done on the fly by ThoughtSpot. You can see this fact table was joined to multiple dimension tables, etc. And this is essentially the SQL that was created. So this SQL gets passed to your Databricks right here. I can do a new query, run it over here, and it'll give you the results exactly the way you saw it in ThoughtSpot. So as you see, this is live analytics. This is live query into your Delta Lake, into Databricks. Now, let's say I have more questions. I need more details around, because I need to do a deeper analysis on my result sets. Let's say I want to see this and do, apply a filter, say in the last 6 months, for example, right? I go search it. So now I get a better data set. I get a little more pointed data set, right? I can also use things like, filters. I can do top, say 14, for example, right? I can go like that. Boom. So as you can see, this is on the fly. ThoughtSpot is generating the SQL, understanding the joins, because ThoughtSpot is schema aware. So you don't have to predefine all the joins. It understands all that, sends the query to Databricks, brings the results back, and gives me a visualization. Say I don't like this visualization. I need a different visualization. I can just choose a different visualization. I can do a stack column, for example, and change the visualization on the fly. If you don't like the graphs that are presented by ThoughtSpot, you can bring your own charts. There are APIs that we allow that you can pull your own charts and give it your own look and feel. Right, now let's do this. Now, the other feature of ThoughtSpot is, as you saw, I can see, live query. I can also ask more questions of my data. I can get more curious. And there's a feature we call is drill down or drill anywhere. So in this data set, I can drill anywhere I want. I do not have to have any predefined drill paths. Just right click here, drill down. And here I want to see my freeloader status. Because I want to manage my churn, I want to see who are my customers who are on the free subscription, who are most, there's a propensity for them to churn, meaning not sign up again. So I'm going to go look at the freeloader status over here. As you can see, I can drill down anywhere. I get my freeloader status. So now it tells me that this customer base over here is likely going to churn, where this is not a freeloader, they already paid subscribers. So let's get further details into this freeloader status. Let's go drill down again and see customer gender. See where the market is, right? Okay, we see male and female is right around the same. So I'm not going to go, pinpoint one gender versus the other to do my next marketing campaign. So let's do show name. Let's do by customer state, for example, right? ThoughtSpot will create this geomap on the fly. Let's say I'm only focused more on, these are my biggest states, California and Texas. Let me just do a versus keyword, California versus keyword Texas. Boom, so I can get only the two areas here. Look at the SQL that gets created. So again, this SQL gets directly sent to your Delta Lake, gets the results. One key feature here is I'm an end user. I do not know SQL, yet the SQL that it gets created, this complex SQL that gets created on the fly. Imagine if you had to use legacy tools like a Tableau or Power BI, where you need a specialized team to create all these reports for you. An end user can do that. So you're giving the power for users to ask questions of their data using natural language search terms. Like here, look at the verses. If I had to do that in Tableau or Power BI, it would take me at least several days to create this report for an end user because of my continuous backlog. So we are giving the power to the end users where your data teams can do more high value work rather than just creating reports for the user and getting stuck in this endless loop of a backlog. So I showed you some key things over here. I showed you drill down. I showed you the live analytics. We'll just show you how all this works also together. Once I created this data, I brought in the tables, we have what we call a concept of a worksheet. This worksheet basically acts as a lightweight semantic layer as well as a governance layer. So you're only exposing data to your customers or to your end users that they have to see. You're not giving them this entire data set within your Databricks. You're not going to expose your end users to this interface. You can just create this worksheet based on this Spotflix tables over here, create this worksheets, the joins, like I said, ThoughtSpot is schema aware, so it understands all the primary foreign key relationships, builds all the joins on the fly, and then you can give this to your end users to do searches, show name, etc. The other cool thing you can do is if you like this answer, what you do, you can pin it. You can create your own dashboard or your live board, keep pinning it, right? You can do top 10, right? Go. Pin, right? And I can now go see my live board. I can see what I have done. See, I've created my own dashboard that I can interact with on the fly. So if anything, right, we're doing a live query, it is interactive. There is no data movement, as you saw, right? Everything is live query into Databricks. I also showed you the drill anywhere within the data set. It's not only drill down with no predefined drill paths. And We also saw that if you do not know SQL, no problem. So with that, I think I've done with my 5 minutes. I'll hand it back to Zuza and Renz. If you have any questions, I'm here to answer that.
Thank you so much, Adi. It was super exciting to see, and also really cool to see how seamlessly it integrates with Databricks.
Exactly. Yes.
Yeah, it's really cool. So yeah, basically with the technologies like Databricks, Approx.what, you're really at the top of the game. And we believe with Revo data that organizations really should get more value out of your data. And that's why we're selecting technologies that really fits to a good data analytics ecosystem. So what you see on the screen is the technologies that we usually work with. So in this session, you saw Databricks, basically one platform for all your analytics and data science use cases. You saw Approx.what, basically your self-service tool for any type of user within your organization. But we also partner up with, for example, Fivetran to easily ingest data into your data lake, or dbt for your data transformations. All easily integrating with AWS, with GCP, with Azure. And with Revo data, we'll try to assist companies basically finding the right mix, finding the right solutions to get faster up to speed with data use cases. And if you can go to the next slide, Susan. We do that with a couple of things. So we can help with starting up, doing, for example, a quick scan, helping out with data and AI strategy. We help out with solution designs or data product management. But also when we help out with implementing data use cases, we also take care of that that the operations are included in there, so that it lands right in your organization. And with that, we're at the end of the demos. Please, if you want to have any information about these technologies shown today in the demo, reach out to us through the email or telephone, or visit us in Amsterdam. I'm also curious if you have any questions, or what would you like to see next in a follow-up session. For that, we open up a Menti, so you can, with your phone, scan the QR code or go to menti.com and fill in the code that you see on the screen. And we list a couple of topics that might be interesting for you in kind of a deep dive, such as Delta Live tables, where I'm super excited about, or MLflow, which was really cool, with what Susa showed, or AutoML in that case, or other technologies that we can connect with Partner Connect in Databricks to easily connect to with Databricks. So please fill in any topics that you would like to have a deep dive on, and we'll look at the feedback there, and hope we can prepare something more deep diving into for our next session. Looking at the Q&A or the chats, if there are any questions there, I see there was a question from Vivek. Is query created selected by Approx.what is also a most performant one? Rolf already answered the question. Approx.what constructs the query in real time and pushes that down to the underlying engine. It will take into account the underlying engine specifics. And Rolf likes to share a lot more on how that exactly is in detail after the session. Thank you, Vivek, for your question. and we directly see the results automatically. Great.
Yeah, I've
Dot the live team.
posted the code in the chat again in case anyone missed it. So it's right there. Yeah.
Perfect. Dot live tables and MLflow. Okay. Thank you so much for your feedback. And thank you also so much for attending this webinar. We look forward to hear more from you as feedbacks, or if you have any interest in any of these technologies. I'd like to also thank all the speakers, Suza, Rolf, and Ali. Thank you so much for joining in, and hope you liked it. And we'd love to see you in a following session again, talking more about the topics that you see on screen that are more popular. Thank you so much, and have a nice day or have a nice evening.
Brilliant. Thank you everyone for joining, and please do join us at the next Source Talks event. Thanks.